Alrighty, let's start out chapter 7 in the right way with a little excitement. We're starting inverse functions. So this section will introduce us to inverse functions. Inverse functions undo what a given function does. It performs opposite operations and in reverse order of the given function. So not only do they do the opposite operation. Opposite operation means like addition, subtraction, opposite operations, multiplication, division, opposite operations, but they also do it in the reverse order. All right, we'll play that Guess My Number game in class, but we'll move on. So our introduction to inverses. So it says a picture of Anita's function machine is shown at right. When she put 3 into the machine, 7 came out. When she put 4 in, 9 came out. And when she put -3 in, -5 came out. So when we make a table, all right, 3 is the input, 7 came out. 4 is the input, 9 came out. And then -3, -5 came out. And first thing it says is explain in words what the function is doing to the inputs. So here we are multiplying by 3. 3 times 2 is 6, plus 1 is 7. 4 times 2 is 8, plus 1 is 9, and -3 times 2 is -6, plus 1 is -5. So the first thing we're doing is multiply by 2, and then we add 1. And then we're going to write our equation. So I'll start with y equals x. I'm multiplying that x by 2, and then I add 1 to that. So that'd be my equation. It then says the function machine is starting to work backwards. It's pulling outputs back up into the machine and reversing the process and returning the original input. If 7 is pulled back into the machine, what value do you think will come out the top? Explain in words what the function is doing to the inputs to get the outputs, and then write the equation. So here now, if it's pulling up 7 back into the machine, 3 would have to come out the top. So now our input is 7, our output is 3. Same thing, now if we are pulling 9 back up into the machine, 4 would come out. And if we were pulling -5 in, -3 would come back out. So now what are we doing to the inputs to get the outputs? Well, we are subtracting 1 first, and then dividing by 2. 7 minus 1 is 6, divided by 2 is 3. 9 minus 1 is 8, divided by 2 is 4. And -5 minus 1 is -6, divided by 2 is -3. Which would give us the equation y equals, I have to subtract 1 from my number first, and then divide the whole thing by 2. And these are examples of inverses. Notice we multiplied by 2 and then added 1. We talked about how inverses were opposite operations and the reverse order. So the reverse order, we subtracted 1, which is the opposite add 1, and then we divided by 2, which was multiply by 2, opposite of multiply by 2. So we did that in the reverse order as well. All right, inverse notation. So a -1 in the exponent is the notation we use to signify inverses. So this exponent -1 in the input is pronounced f inverse of x. All right, so here there are 2 ways that we can find inverse equations. The first way we're going to learn about is the word way. So with the word way, you're going to write down the steps to the original function. If you're having trouble, substitute a number in for x and follow PEMDAS. So for example here, I'm going to write f of x, and I'm going to write my steps down. So if I were to plug a number in for x and I follow PEMDAS, the first thing I'd have to do is multiply by 2. After that, I would add my 9. Multiply by 2, add 9. Those were writing my steps, so that's step 1. Step 2, write the steps to the inverse. the inverse function starts at the last step of the original function and performs the opposite operation in reverse order. So I'm going to write f inverse of x, so the f to the negative 1x, again, f inverse of x is how we say that. We start at the bottom and do the opposite operation, working in the reverse order or working up. So opposite of minus 9 would be, opposite of plus 9 would be minus 9. So the first thing I would do is subtract 9. And I'm working backwards. Opposite of multiply by 2 is divide by 2. And then what you're going to do is you're going to write f inverse of x, leave some space and put an x. Then perform the steps of the inverse to the x. So I'll write f inverse of x equals, put that equals there. Leave some space, put an x. First thing I'm doing is subtracting the x by 9, so x minus 9, and then I divide the whole thing by 2. So just make sure either that whole fraction line is there, or you can put that x minus 9 in parentheses as well. And that's my inverse. For number 2, I have g of x. If I plug something in for x, there's really parentheses underneath there, so the first thing I would do is minus 6. And I do exponents, which is the cube root. And then the last thing I would do is add 3. I write my g inverse of x, and again we start at the bottom and work our way back. So opposite of plus 3 is minus 3. Opposite of cube root is 2 cube. And opposite of minus 6 is plus 6. I write my equation, g inverse of x equals, I leave some space, put an x. First thing I'm doing is minusing 3 from that x, and then cubing that whole thing, so I must put parentheses around that whole thing, and put the cube, and then at the end I'm adding 6. All right, you can try these other two on your own. And then there's also another way that you can find inverses, and that's what's called the algebraic way. For right now, it's up to you, but eventually we do want to get towards the algebraic way. But for now, you can do either the word way or the algebraic way. So if the equation is using function notation, you're going to change the f of x to a y. Okay, so here I am using function notation, so I change that f of x to a y, or if it's h of x, whatever, just change that to a y. The next thing you're then going to do I skipped the most important step here. Step 2 is you're going to switch x and y. So I get x equals 4 times y plus 1 cubed. Step 3 then, we're going to solve the equation for y by using the undoing strategy. Okay, so that's PEMDAS backwards. So now I'm doing PEMDAS backwards for this step here. So there's addition here, but I can't undo that yet. So I'm going to undo the multiplication, because again, I'm trying to get the y by itself. That's the goal. So I'm going to divide by 4. And so I have y plus 1 cubed equals x divided by 4. And then I'm going to take the cube root. And so I have y plus 1, because the cube and the cube root cancel out, equals the cube root of x divided by 4. And the last thing I'm going to do is subtract 1. So I'd have the cube root of x divided by 4 minus 1. Notice how that minus 1 is outside the radical. And then once the y is by itself, change the y to f inverse of x. So my final equation should be f inverse of x equals the cube root of x divided by 4 minus 1. And that's step 4. Here. All right, one more example. Again, I'm making my h of x a y for right now. I'm going to change my x and y next. And so we just did steps 1 and 2. Step 3, now we're going to solve for y by using our undoing strategy. So I'm going to undo addition, subtraction, but remember, when you have a fraction written this way, there is parentheses, so I can't get to that plus 1 yet. So I'm going to have to get rid of the 7 by multiplying 7. So I'd have negative 2y plus 1, the 7's cancel, equals 7x. Now I can undo the addition and subtraction, so minus 1. So negative 2y equals, remember these are not like terms, so it'd be 7x minus 1. And I would divide everything by negative 2. So my final answer, well, close to my final answer, y equals 7x minus 1, all divided by negative 2. And then just the last thing I want to do is use that proper function notation. So I'd have h inverse of x equals 7x minus 1, all divided by negative 2. And that's our intro to inverses.